Okay, then the average output power. Average output power means that the average output which measured at the load. The output power here, PDC, is equal to Vm squared over 4R. Or when we calculate in terms of we able to calculate or find the RMS value. So P equal to I square R. So the I here is I RMS. We have so many formulas for P, and we provided out of the three parameters that we have. P equal to V square over R, P equal to VI, P equal to I square R. So the three formulas here can be used at any condition provided the two of three values is available. So let's say if we have here, we know the values of R, so we are going to find the I. So here should be used I RMS, and I RMS, or V unknown, so V is the V RMS. P equal to V square over R, so V here V RMS, or I square R, so I here is I RMS. So this is the average output power. Average output power. Then the power factor is the P out. Power factor is equal to P out over P in. So P in is our RMS input times I RMS voltage. V RMS in, I RMS in. V S RMS, I S RMS. The output here is our DC output. DC output here, V square over 4R. So V square over 4R divided by V RMS. V max divided by Z2 is our RMS value. V max divided by 2R is our I RMS. See? V max over 2R is our I RMS times V RMS. V RMS. V RMS here is the V RMS of input. This is V RMS of our output voltage. Input voltage is V square over 4 Vn over Z2. So the value is that. Power factor for half wave uncontrolled rectifier is 0.01. So actually all the formulas here is not so critical, because we are not expecting you all to remember the formula. It will be given as appendix in your test or exam, and we encourage you all to buy the books, because you can always refer back to the book if you require to recall any kind of formulas to strengthen your facts during your career later. But from the circuit analysis, to understand what are the conditions affected at that time and how to generate the waveform, the response waveforms. So that one here you have to master, you have to understand, and you have to remember. But this one you can refer back to the books, so it's not an issue. Okay. So for example, we have here V source sine wave delivered to the load. We have 120 volt RMS, 50 Hz, R of 15 ohm. Assume the diode to be ideal. So determine, means that calculate the average load current. How much the current that pass through the line to the load, from the source through the diode to the load, the average values. And what are the RMS value of the current. Then how much is the power absorbed by this R, and how much the apparent power supplied by the source, and the S value, the P value. Then how much the power factor, and power consumed by the load over the power delivered by the source RMS power. So you calculate. In the lab, I shall ask you all to simulate, compare with what you calculate theoretically. So instead you are able to show your understanding and or your capability of running the simulation to prove and to cross-check your theoretical calculation versus your simulation. And okay, for solution, so the first thing we need to find the average load current. So I out load current here. What is the measured load current? So I out equal to V out divided by R. And V out here divided by R. But for half-wave rectifier, V out is equal to, which is we previously known that V max divided by pi, and V out equal to V max divided by pi. So I out equal to V max divided by pi divided by R. So V max here is equal to 120 times 2. And if you refer back to the question, it gives you in RMS. So you have to change again into peak, which is you have to multiply with 2. Divide by pi, then divide by 15. So you please write the sequence in terms of formula nicely, because if you end up with the wrong answer, still we have marks for the steps. Okay. So 120 divided by 2, you shall get 170 divided by pi divided by 15, which is equal to 3.61 ampere. Don't forget to put the unit. So if you omit the unit, so you have a reduced mark. So 3.61 ampere. You might have 3.60, so it doesn't matter, it's still within your answer. So the step, please follow. Okay, then for B, so what is the RMS load current? So I RMS, which equal to V out or VDC RMS divided by R. So I equal to V over R. But V out RMS is equal to, we have no in the previous slide, which is equal to Vm divided by 2. So VRMS here, RMS voltage equal to Vm divided by 2. Average is equal to 0.318 volt Vm, or Vm over pi here. Vm over pi. So we shall have this IRMS is equal to Vm divided by 2 divided by R. So Vm is 120 set 2 divided by 2 divided by 15. We shall have a 5.67 ampere. So you can solve gradually. 2 times 15, so you get 5.67 ampere. Okay, so make sure that you follow the step. Write the formula, write the inner formula, write the steps, and then go to the answer. Don't skip from just put the step and then answer. You might have a wrong answer, so you don't have chance of getting marks for your steps. So please be in mind that you have many steps here, proper steps you provide, so high chance of getting marks or not losing your marks during exam and test. Okay, for C, what are the power absorbed by the load? P load. So what is the power absorbed by the load? So P equal to I square R, and P equal to I square R, or P equal to V square over R also can. And so what is the power absorbed by the load? So P, you can use I, is equal to I square R. So at this time, I is your IRMS, and IRMS. So your IRMS, which you have calculated just now, which is 5.67 ampere, equal to 5.67 square times 15. So you will get 482 watts of absorbed power by the load. Then D, you need to calculate the apparent power supply by the source. What is the power supplied by the source? Which is your power, S, apparent power. So S is equal to V in times I in. So here the V is in RMS as well. I also in RMS. And V RMS times I RMS. So 5.67 times V RMS, 120 volt. In the middle of calculation, you can omit the unit. So you have stated here 130 volt RMS 50 Hz. So 120 times 5.67, we shall have a 680 volt ampere. And this is 680 volt ampere. So E, the power factor, is equal to absorbed power divided by apparent power, which is P over S, 482 divided by 680. So you will get 0.71. Power factor, we don't have unit, so the power factor is 0.71. Okay, so that's done for solution example A, example 1. We shall prove it during our lab hours. So I will pick up randomly from your group to present the values in simulation. So you have to simulate and make sure that you produce the same values as mathematical calculation we have performed just now. Okay, to prove that the theoretical is correct, or to cross check your simulation is correct or not. Okay. Okay, means that you have to perform this example, find all the values, no more determine, but simulate. Simulate to prove, to find the values here. Okay, please proceed with your simulation. Thank you.